I want to take a look at an example of a hypothesis test, and specifically this one's going to look at a z-test and walk you through kind of the whole process so you can see how it all fits together, and then hopefully use this information on your homework for z-test. So our question reads, a manufacturer of chocolate chips would like to know if its bag filling machine works correctly at the 438 gram setting. It is believed that the machine is underfilling the bags, thus cheating customers. 37 bags were sampled and found to have a mean of 435 grams. Assume the population standard deviation of 14. Using a 0.05 significance level, determine if the bag filling machine is underfilling the bags. And the first question we have here is, this is a one mean z-test. What makes it a one mean z-test is the fact that we know the population standard deviation. Knowing that population standard deviation is the distinguishing characteristic between whether you do a Z or a t-test. So this is a one mean z-test because the population standard deviation is known. And the first step in any hypothesis test is to state the hypothesis. So when you're trying to identify the hypothesis from the paragraph, you want to look for words like believe, conclude, claim, think. And oftentimes it's also restated again at the end of the problem. It's stated here in this problem, it is believed the machine is underfilling the bags. And then again, it's stated at the end, determine if the bag filling machine is underfilling the bags. Now, you do have to interpret what is meant by the idea that it is underfilling. You have to think about it mathematically and whether that would mean equal, less than, greater than or equal to, less than or equal to. I hope you realize that underfilling means they're not putting enough or it's less than what is supposed to be in the bag. And because it is less than, that statement actually represents the alternative hypothesis. So I'm going to make a little note out here to the side that the alternative hypothesis is the one that's given. And we're saying that the mean is less than the setting on the machine, which is 438 grams. The null hypothesis will be opposite of that. So it would be the mean is greater than or equal, to 438. Then you need to identify the information that you need to calculate the problem. And you may not be familiar with these symbols. I believe in the homework it's written out. Mu is the population mean, and the population mean is always the value that is in your hypothesis. So in this case, I believe that is 438. Sigma is your population standard deviation. And if we go back and look at the story again, I believe we'll see that that is 14. X bar is the sample size. X bar is not the sample size, it is the sample mean. Getting ahead of myself. Okay. Sample mean. N is the sample size. And alpha is the level of significance. Now, all of these numbers should be given to you in the problem. So let me go back up here to the problem and read here, see if we can find it. It says 37 bags were sampled and found to have a mean of 435 grams. And then it tells us to use a 0.05 level of significance. So again, all of that information is in the problem. So back down to my table. My sample mean was 435. My sample size was 37, and alpha is 0.05. We also need to determine whether it's a one-tailed test or a two-tailed test. To make that decision, you always look at the alternative hypothesis. And it's based on the symbol. So if I go back up here and look at my null hypothesis, and I'm going to kind of make a comment off over here to the side, it is considered or would be a one-tailed test if the alternative hypothesis contains either less than or greater than. It is a two-tailed test if the alternative hypothesis has not equal. So looking at this symbol, I see I have a less than, which tells me that I have a one-tailed test. Then to calculate the z-test statistic and the p-value, these two pieces of information are found either using the calculator or the website. And quite honestly, most students are finding that the website is much easier to use. So let me see if I can pull that up for us, and we'll take a look at it. Okay, so we go out to the SochSci website, and we select z-test calculator for a single sample. And then I need to enter the information. Now, one little catch here when entering the information is on the website, they request the variance instead of the standard deviation. To find the variance, you have to square the population standard deviation. So in this case, if I square 14, I get 196. So all the information I need is there in my table. So I'm going to go to the website and enter it. My population mean from the hypothesis was 438. My population variance is 196. My sample mean is 435. My sample size was 37. I am using a 0.05 level of significance. I need to indicate it's a one-tailed test. And then I calculate. And at the very bottom of the screen, I highlighted it there in blue, it gives me the z-test score and the p-value. So z is negative 1 point. The z-test statistic would be negative 1.30345, and the corresponding p-value is 0.0968. Then I need to make a decision about whether to reject the null or fail to reject the null by comparing the p-value to the significance level. And the guideline here says, now I'm going to scroll down a little bit and write that guideline. The guideline says if p, if p is less than or equal to alpha, then we reject the null. But if p is greater than alpha, then we fail to reject the null. Okay, so that's the rule. That rule applies all the time, every time to hypothesis testing. So if I come back up here and I compare my P, which is 0.0968, to alpha, which is 0.05, 0.0968 is greater than 0.05. Since it's greater than, according to the rules, I'm going to fail to reject the null. And then lastly, we write the conclusion, and we write it in the context of the problem. So we fail to reject the null. So we're basically saying that the population, that the bag is not underfilling the bags. Okay, because we're saying that it's greater than or equal to 438. So we would say at the 0.05 significance level, the bag filling, the bag filling machine is not underfilling the bags. Okay, so there's your conclusion, and that would be the end of that particular hypothesis test.